Problem number 3, I'm going to go to the graphing application, and to graph it out, I'm going to graph out what they want me to graph out. Let me close this first. All right. So we're going to graph out, y equals, we're looking for roots. That's x cubed minus 7x squared plus 12x. And we have an answer key to verify that what we're saying is correct, by the way. And let's see what we get over there. Now, someone says, oh, I don't see the roots. I see some of the roots. I was expecting to see 3, though, right? So I'm going to zoom out. And what I'm going to do now is I'm going to zoom into that region. And the region, I'm going to look at this region over here. So what I want to do is I want to find the 3 roots. I'm looking at it. The root over here, I'm going to say, approximately 0.7, 1.7, and 4.7, right? This is an approximate. So what I'm going to do is I'm going to go to the equation, and what I want to do is find the root. So let's just type the first root in. I want a root. I'm going to say 0.7, 0.7. And what do I see? X is really not 0.7 according to their estimation. It's 0.6228. You notice the y again, it's not exactly 0, but it's approximately 0. All right, we were expecting that. What's the other root looking at? I don't know, about 1.7, I'd say. Let me just change this, 1.7. What am I seeing over there? Well, 1.7261. It's far more accurate than my visual. All right, what's the y value? Again, approximately equal to 0. What's the other one I'm looking at? I don't know. Let's say 4.6 this time. What am I getting? 4.6511. What's the y value? The y value, again, is relatively close to 0. All right, again, the x value here, 4.6511. All right, so there's not much else to say about that. If we're using technology, it's not a bad thing to be doing. All right, now granted, Wells did not have this at his disposal, but you do. You have software at your disposal. I also want to encourage you that don't feel that this is the only piece of software you could use. For example, I want to go to another application. I'm going to launch Sage. I'm going to launch it. And Sage is a computer algebra system, and I'm running it from the terminal. And so the one thing I want to point out, the nice thing about Sage is Sage can solve things much quicker than I could do by hand. So I'm going to say solve, and I'm going to solve x cubed minus 7 star x squared plus 12 star x minus 5. The double equal sign indicates it's an equation equals 0. I want to solve for x. I'm expecting to see 3 solutions, by the way. Okay, it solved it. Now, someone says, I don't understand that, and you're right about that. A lot of students don't understand what's being given back to me. And I'll be honest with you, it's a little odd looking to me, all right? So there's other commands you could use, all right? But that looks pretty odd to me. But there's 3 solutions over there. But they look pretty odd to me. And that's the problem with Sage. Something's going to return something that looks odd to you. But I'm going to look for another command, and I'm going to look for a command called find root. But I really can't remember the name of it. So what I did was I typed in find _r, and then hit the tab key, and I see it. But I don't know how to use it. So I'm going to put a question mark there, and I hit enter. And what does it tell me? Find root. Well, a lot of work over there, isn't it? But you read through that. Let's see if we find an example. And I'm thinking, I'm looking at some examples over here, and it looks like they're doing find root of f. Right? You get some examples over here, right? Now, granted, you might look at this and say, I don't know what to do with that. That's possible. I read a lot of things I don't know what to do with it either, but I'm going to give it a shot. All right? So find root, and I'm going to give it a bound. Ready for this? Let's find root. Find root. This is another piece of software. Oh, I'm getting a little tired. I'm going to copy this in. And I'm going to give it bounds on the root. I'm going to say, find the root between 0 and 1. And what does it give me? It gives me a nice long number. What does it say? 0.622. And that's this number over here. Let's say I said find root and I want to go between a different bound. I want to go between 1 and 2 now. So I'm telling Sage, concentrate on just between 1 and 2. And what does it give me? Well, 1.7, yada, yada, yada. We got this with the other application as well, but not to that level of accuracy. What's the other one going to be between 4 and 5, right? So let's put that down, 4 and 5. I'm giving it a range. And what's that going to be? 4.65104. Let me go to the key. I want to point out these answers, not to a level of accuracy that Sage has given me, but 0.62, that's there. 0.173, rounded properly, and 0.65. Yeah, everything's looking good. I do want to point out, though, if I did this, f of x is, and that's going to be this over here. It's a function. And I want to show you something. I want to show you f evaluated at this number over here. I'm just doing a copy paste, by the way. What should it be? It should be about 0. Let's see what happens. It's not 0, but it's really close. What is it? Minus 6.9 times 10 to the minus 17. Let's do the other one. F of, let's try this one. And again, it should be 0 if that's the actual root, but it's not. It's an approximate root. So what do I get? Again, it's virtually 0. That's minus 1.25 tenths to the minus 14th. Let's do the last one. And again, if this were the actual root, it would give me 0. No, it's not giving me 0. It's giving me something really close, though, 2.13 times 10 to the minus 14th. So things really are working nicely. Sage gives me a really good approximation, by the way, but it also gives me exact solutions, which I'll be honest with you, are horribly confusing to look at this point. Thank you.